Hi, my name is Michael, and I'm a technical writer for a software company in Sydney. I got into technical writing via a bachelor's in creative and professional writing. So my technical background was only initially what I dabbled in personally. Moving from contracting as a tech writer across different fields to a permanent job in software came with some interesting challenges and opportunities. One of those main opportunities is tooling. There are many tools out there for a writer, technical or otherwise, but being in the software field has increased my visibility over potential tools, helpful for a range of functions for my role. However, those tools tend to be complex or they require significant configuration. My current job requires the generation of documentation for a wide range of products, each developed by siloed teams. Developing consistent documentation for all these products can be complex and time-consuming, especially with our preferred tools. This is where Docker comes in. Docker is a paid product, but it's free for an open source community, small businesses, or for individual developers. It is essentially a product that allows you to deploy small virtual machines that you can set up and deploy with like a working environment, essentially. It works on any major platform, Windows, Mac, or Linux, and is an easy way to set up a consistent environment for your workflow. Think of a Python virtual environment, but not restricted to Python. For my use case, I wanted to set up Sphinx, a Python project that can be used to automatically document APIs and generate documentation from a collection of source files. But I didn't want to have to set up Sphinx for each team. Some package updates can easily break everything, though I could freeze versions, but mostly I didn't want to set up builders for all these different projects that use separate infrastructure. Setting up a Docker image for this use case is relatively simple. Using a file with no extension called a Docker file, which I will share with VS Code here. For example, this calls a base image right at the top. In this case, a default Ubuntu 2004 image, and then you implement various commands, including basic bash operations. This particular file sets some environment variables, runs some commands to install required packages, copies some files into the image to use as templates for my specific Sphinx configuration, and sets a general entry point for when it's used. Sphinx normally requires a configuration file for each project, which can grow unwieldy with how extensible it is. But this way I can use some basic Python scripts to set templates with the generic configuration I want to use across everything, and then use those templates to generate the required configuration for a much simpler YAML file within the project, because Python is really good at parsing YAML. Docker builds an image with a very simple command line. So I'll just share my PowerShell here. Docker build -t, the name of your image, and the location of the source file. The generated image can even be used as a base for another Docker image. The virtual machine can be started from the command line as well, and is relatively simple. So for this one, even if you're mounting your local file system, which is what this PWD is here, it's a pretty simple command. So GitLab has native Docker support for these images, and I believe it's fairly easy to use in GitHub as well. In my particular case, this image that's built is then uploaded to an Artifactory server, though I think GitLab has an internal Docker registry, and then every team across my company can then access that image and build their documentation with a fairly simple command. Docker images build as layers, which is what these caged 2 to 8 are here. To run this container locally, I can just essentially summon it from where it has been built with the correct name. And it can even be run interactively. So instead of the entry point I've defined, this runs it as just a bash, like SSH into the machine, essentially. So Docker provides a massive range of functionality, and this barely scratches the surface. But even for less technical people, it presents a range of opportunities. For example, being able to run Ubuntu to play around, familiarize yourself, and then have that container completely disappear once you're done, fixing any mistakes and taking no room on your machine. It's an extremely versatile tool, and it's been very helpful for me personally.